I wanted to introduce myself. My name's Jeremy Bentley. I'm the founder and CEO of Smartlogic. We started Smartlogic in 2006. Our customers are industry, information-intensive organizations who care about data quality. A lot of the data that they work with is buried in text. That's why I got to speak at Text Analytics, because we're very good at doing two things. One is making great data, that is the synthesizing of metadata and data out of text, right? So that's actually turning it, because the use case that we started Smartlogic on is you can't ask a PDF a question. And if you think about it, you can ask a SQL database a question, but you can't ask anything that is text-related a question. And that was our use case to start with our software. And the second thing that we do is we make data great. And that's all around the concept of data quality, data veracity, right? So it's not good enough to have data. The data has to be clean. Very specifically, as you get more and more into the analytical world and more into asking machines to make insight, the data has to be clean on the way in. Otherwise, the output is very noisy, right? And I think everyone knows that. If you're here in you're in an AI string session, the noisier the data, the poorer the quality of the data, the noisier the output. You end up with information that is not trusted by the business because they can't see the correlation between the data and the output. Partly because the data is dirty and they know that, and partly because if the AI is not transparent, they don't understand it. They don't see how it came up with a conclusion. So I said I'd do some use cases. I've got a small vehicle safety use case to use as a beginning example, and I've got a distribution use case. And before I do that, I've got, I think, go that way. What's going that way? A quick, brief reintroduction of what AI we're talking about. So AI is a very large sector. Everyone, I know that our business users say, I just want some AI, go and make it so. But actually, it's everything from robotics all the way up to deep learning. And the only bit that Smartlogic are capable of talking about is that sector there. Everything from unsupervised and supervised machine learning through to natural language processing, including content extraction and classification. So please don't ask me questions about image recognition. I know nothing. I know a huge amount about the stuff in the grey. In fact, my whole team does. And the last bit of credentializing for Smartlogic is, this is the recently published 2019 Metadata Management Magic Quadrant out of Gartner, and Smartlogic is, as you can see, a leader in the top right quadrant. There is nobody else in this presentation or who was at this show who is in that sector. Right? We're very highly specialist. Text analytics company, and our job is to make great data and make data great. So what do I want to talk about? Here's the old way of working. This is the normal insights place that a business finds itself in. The siloed enterprise where you've got audiences, people who are doing different jobs, who are interfacing with systems. Those systems, everything from customer analytics, BI analytics, AI analytics, new systems like robotic process automation and business applications, chatbots, portals, websites. And then down below you've got your information services. And information services is everything from databases through to unstructured, search, content management, all that stuff. And the thing about the siloed enterprise is every time the meaning of all the data is implicit in the links between the business apps and their own data. So you end up with nowhere to go, one place to go for both data and metadata. The second thing I want to draw your attention to is there is a confluence of technical innovation which is driving change. And this is a once in 30-year type of thing. Right? So we've lived with relational databases for 30 years. Before that, we had hierarchical databases in COBOL, relational databases in SQL, and a whole load of great analytics. But there are three things that are occurring that make this world more interesting and offers us a new way of working. The first is the open link data. So, you've all probably know about it through the things like geonames and DBpedia and all those stuff. But those are the
the obvious ones, but there is a massive resource, particularly if you're in pharmaceuticals or in medical, for the open link data, which is free shared data, communities of practice who contribute to it, right? Which allows us not to have to go and rewrite lists of things like currencies or countries or locations. No one should have to be maintaining that anymore. It's all open. The second is semantic AI, which is Smartlogic, right? Which is a whole way of processing text-based data, right? To come out with high quality, trustable, high veracity data. And the third one is graph databases. They've been around a while, right? But actually we're now seeing, because these other areas have come into the fore, the concept of a post-relational database, a new way of working with data, is very powerful. Sometimes people, if you combine it with knowledge, they call it a knowledge graph, but often it's just called NoSQL databases or triple stores or whatever. But it's those three together, which is the innovation that is driving what our customers are calling 10-10 projects. Compared to the old way of working, which was get out a data mart, do some ETL, ask your users what extra columns or questions you need to ask. If you take and adopt these technologies in their entirety, you get a 10-10 project, 10% of the time, 10% of the cost, compared to the old way of working. Right? And what is it that causes that? Coming up. We've now taken all those, oops, oh, it is working now, look, great, that obviously have to be here. We've now taken all those links, all those individual links, and we've given the architecture, the enterprise architecture, one place to go, so that all the systems applications and all the information systems have a place to go for the meanings, the concepts, and the relationships, which can all be harmonized and regularized and authorized in one place. And this, therefore, means that your addressable enterprise metadata and data is in context, and it's using this graph, knowledge graph. Okay. So that's what our customers are typically installing, not necessarily across the enterprise to start with, often in a department or as a start, and then seeing the value of these sorts of 10-10 projects and adding silos into it, so that in the end, you've got the enterprise with one place to go for all their meanings, relationships, and concepts. So we talk about text. Well, here's a bit of text. It doesn't matter what it is. It's purposely opaque. And then we think about all the different text-based systems that we've got. You have to think about e-commerce sites, social media threads, chatbot conversations, product sheets, catalogs, engineering notes, all the way down to schema names in databases, special instructions in payment fields, metadata values. And this is the lifeblood of every organization. Right? The minutes of the board meeting, the minutes of the department, the findings of the research, right? And so data, but we think about data, and everyone says, oh, but 80% of the, 20% of the data is in data, and 80% is unattainable because it's all locked up in content or in text. That is indeed true. So the way of working today is not just data speed, but it's also humans. Humans are staring and comparing at reports, pulling out the data they want, putting them into data systems. Right? And those data systems are very, that's a very time-consuming effort. Websites, tweets, emails, news is how they arrive, presentations, spreadsheets. All of that is if you like, the text asset filled with data arriving to us in all these different formats. Right? And so how do we deal with that? How do we process it? So our next thing I want to ask you, and this is starting the vehicle safety thing, is how much data is in a paragraph, right? And how do we make use of it? It's a little ghoulish, but it was Halloween the other day, so we can talk about fatal accidents. But here's a typical AIR, accident investigation report with a date. EMEC investigatory team identified that the crash involving vehicle was caused by the accelerator pedal sticking and the servo seal failing in the master brake cylinder at the same time. The Police report that the vehicle was travelling at between 60 and 65 miles per hour when the car hit the highway bridge. First responder log states that the two occupants, an adult male and woman, were killed instantly. Right-hand side and front airbag deployed, the left-hand side partially deployed, and the one in the steering wheel remained intact. The accident occurred at mile 131 on IS 60. How many paragraphs are like that in an insurance company or in a car manufacturer's? So every time there's an accident, there's at least 20 text artifacts like this, where everyone puts it all together. And how do we process that? So here's that sentence there. What we have is raw text, right? But what we have to turn it into is data. How do we do that? Well, you need, in our world, our product's called Semaphore, but you need a very strong semantic AI engine that is able to take this very loose, ambiguous text and turn it into comparative data so that you can compare one accident investigation report with another and also include that. So if we look at, remember what it was, we look at that AIR becomes accident investment report, that's pretty easy. The data report's given, that's pretty easy, but we can at least highlight, there's nothing to say what is the data report, but at least we know it is because of its position, that's easy. But EMEC is actually the investigation team, we know that that is, so that's been, if you like, harmonized into the electrical mechanical investigation team. We've identified using the good NLP and pattern matching the fact that this is a VIN number, so we've given it the VIN number. Then if you know that the vehicle identification number, how you know how it's formatted, you can actually say, well, actually, we've got the VIN number, so we know that the country that the vehicle was built in the United States, it was done by Ford Motor Company, it was a Mustang, and actually if you carry on, I just didn't have room on the slide, you can carry on with model, age, series, thing, out of all of this. So you're decrypting what is deep hidden secret knowledge, basically the VIN number, so that somebody else, if you're doing analytics later, you've now got the country and everything all split out. We've got the cause somewhere in here. It wasn't actually the fact that it talked about the accelerator pedal stuck. We've harmonized that to accelerator fail. We've gone off and found the fail code, right, which might have come out of the computer or the Internet of Things thing that was in the log, but equally we've also gone and found the part number because we can go back here, know that it's this vehicle, we've gone into it, look, we've done the brake fail, we've done the same thing with that. We found this reference here, mile 131 on Interstate 60. We've decided that that's going off to geonames. Red just suggests enrichment rather than harmonization or extraction. And we found where the accident occurred, right? And it was fatal. There were 2 adults involved. This is harmonized, enriched, extracted data for vehicle safety analytics. And then the lovely thing about it is, sometimes, that's all the information you want to know, but then 2 weeks later, the business comes along and says, I know we've got all this data. Can you tell me what I'm investigating accidents that involve airbags that didn't deploy. So then you go through and you have to basically recycle your data, but now you're looking for a different thing. And this is where ontologies come in, because the ontology is the way you describe what data you're looking for in your basic data lake. And now we just take the same text and we can see, oh no, there's much more simple, but actually we wanted the velocity, we wanted the airbag deployment state. Business works in this iterative way, investigating activities based on the data that they've got. They don't know what they need up front. If we'd had to have done this the old way, we would have said, oh, well, don't you worry, we'll get you a nice data mart, we'll translate all the data into the SQL database, we'll give you your previous answer, that, and then the business comes back and says, can you tell me about airbags? And in the old way, you say, well, we didn't have a schema for airbags, so now we've got to go back and do that whole thing again. This is why data creation, data analysis is so damn expensive. That is why the 1010 project using semantics and graph and open linked is much faster. So when you end up with is all these different websites, mobile apps, search engines, all these text-based systems which are processing text-dependent processes, plus semantic AI gets you to speedier products to market and therefore online sales promotions, for example, across all of that. The data veracity goes, you're dealing with data in these systems, which gives them all a nice adverb in the front. We're not trying to, you take your, contract management, and actually what we want is tighten contract lifecycle management in order to prevent revenue leakage, right? So that is the flow. Text-based systems, text-dependent processes lead to good, high-quality data, which then leads to valuable business outcomes at 10% at the time and 10% at the cost. It's worth a go. And here, with a bit of 5 minutes, we have a very fast look at a similar kind of use case. So the challenge is an easy one to describe. We're making things. We're a pharmaceutical company. We're making stuff, right? And we need to get those drugs from here, the factory, to there, and out to our different regions. And we need to do that by putting the drugs in containers. It's a very precise distribution chain, because very delicate products need to be kept in special conditions. They're not allowed to sit in the sun for a long time. They have to be some of them have to be in refrigerated containers that can only be very small temperature tolerances. They go by air or by road to the different areas of the world. Right? We have standard operating procedures, as every company does, to explain how that good is going to get transported, where it's going, what are the temperature and the parameters for the transportation, what is it that should be measured during the process of distribution, so that we make sure that the product is of high quality at the end. Of course, we've got many products, many factories, and each one has to have a thing called a lane, or just basically a route, right? And that route describes what that product needs to look like when it's come out the end, what transport systems it's going to use, who's going to do the shipping, who, etc. And we've of course got, because we're in pharmaceuticals in this case, we've got regulatory authorities who are looking at us and how we do that. We've got regulatory authorities where the drugs arrive. We've got regulatory, and different regulations. And we now need to feed the regulation data also into the standard operating procedures and into the lanes, and we need to get data. So forget if you like, the physical world, go back into the logical world, and what we have is a logical set of data which has come from many different places. We've got many different drivers, which needs to be put into a metadata hub, right? So that you can start to analyze your distribution in a unified way across all of your products. Right? Now, some of the challenge, which we can then go and analyze. Now, some of the challenge is data quality, and some of the challenge is the data doesn't exist, because this lane is actually a document. Right? So, sure, the Internet of Things out of the container that gives you your temperature readings, that's data. But the distribution, the actual description of that particular lane is actually sitting in a document, but we need to turn it into data. So we need to extract the facts out of those documents, and these are 4, 5, 7 pages long, and they've got reams of data in them. Right? So that's what they look like. It's a classic document, and we have to use a lot of AI. Everything from text mining through, finding anchors, parts of speech, vocabulary-based extraction, knowledge modeling, facts extraction, all of those things to get the data from where it is to what we need it to be. Right? So we do that using lots of technology, but equally we also then have to be able to see. We're talking about a regulated industry, right? So our engine that's doing all this extraction needs to be transparent. I need to be able to show the regulator that actually we got this data off this form. It originally was this form, but look, we didn't make a mistake by taking it from here to here. The reason why the engine works is because you can actually repeat that data. It's quite an important aspect of AI, which is having it as a transparent, understandable process, right? So when you go to the regulator or to your head of compliance, you can say, yep, here is the original. We don't lose the links between this one and that piece of data. And actually, this is the rules, and this is the NLP, and this is everything that was applied to actually do this extraction. Right? So that's where the data is needed. And now we have the data out of the documents in association with the data from all the different parts in our hub. But of course, it is... let's just put these three up. We've got our lane documentation with its data that's been extracted. We've got our order data, which is one of the other bits, and we've got the container data. Right. Trouble is, when you start looking at it in detail, you'll see we've got both metadata problems and we've got data problems. This is so common. This happens. It doesn't matter whether it's distribution or anything. The moment you take 3 different data sources from 3 different silos, you're going to have terminology issues, semantic problems. Simple. The origin company name, right, in the lane is actually called the shipping plant name in the order, and the Louisville distribution center in the lane is called the USA Inc. LDC in the order data. Right? Why? Because this came in from supplier management, and this came in from shipping. Right? And the different systems have different references. So how we can't yet have our unified information all in one go because we haven't got a way of comparing. So unless we put in semantics. And it carries on. Here are all the, here's Leiden in the Netherlands. It's called the Leiden Technology Center. The shipper is also known as the container. The transportation service provider is the receiving plant name. This is both metadata issues, in that the columns are called the things that are different, and data issues, in that the actual similar, the equivalence is there, not there. So that lane, we can start to visualize this in the form of an ontology, and we can see that particular lane, form 1, 2, 3, 4, 5, is made up of the Netherlands, actually Leiden and Louisville, and it has temperature control, is active, it's important and stuff. That shipper that was on if we were to highlight this, that shipper is used by all of these different lanes, so we can start to visualize how important that shipper is to our business operation. Right? And we can now start to put in alternative labels, which is starting to clear up some of the semantic coding differences. The problem with the Acme Louisville being called LDC, right? Where am I going? Oops. Yeah. If we now go and press on LDC, we see that it's actually got all of the alternative labels sorted out here. We've also started to add in other metadata like the location data and stuff, so we can start to plot on, nice visualization tools. And the Louisville LDC is really obviously a big distribution center because these are all the lanes that it's running. So the combination of semantic AI, some visualization, right, gives us a very rapid way of being able to see our operations, harmonize our data, clean it up, make it high quality, so that we can actually do nice dashboards that make it all look good, and give you the information that you need to run your operations, such as how are the shipments meeting the requirements of our standard operating procedures? Are there opportunities for gaining additional efficiencies? Are there lanes that are being run that are the same but being run by two different transport companies? All of that stuff, all that analytics, just as a doing in distribution, is now freely available because your data is harmonized, your data is extracted out of text. And your data is enriched in the sense that it is now cleaned up. Okay, that's a little 2 case studies, one in vehicle and safety analytics, and the other in pharmaceutical distribution. But it's anyone's distribution. Right? I guarantee that high-tech manufacturers have this distribution problem too, except they're not regulated. But they do have transport, they do have shipping, they do have temperature problems. Right? It's the same. Hopefully that was a useful chat.